All right, let's do this. Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm the head of consulting practices at InRhythm, and we have a lot of content lined up for you in upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants speaks on latest technology trends in the industry. And this week, Paul, who is an awesome software engineer with us, is going to go over GraphQL for web engineers. And I'm curious to hear about the best practices of using GraphQL. So without further ado, let's get it started, Paul.
Sounds great. Thank you, Parag. Yes, GraphQL for web engineers, consuming an API with a data querying language. A quick overview of the talk. We're going to talk about REST API endpoints and how they can get out of hand, how GraphQL was born, what is it really, some benefits and trade-offs. I'm really excited for the demo where we're going to make some queries with the GitHub GraphQL API Explorer. And then I'll close with some useful links and what to learn next. So REST APIs and how they can get out of hand at times. Usually there's a resource URL for a specific purpose. And the example I have is like a GET request to some heroes endpoint. That would probably return an array of heroes. But if you wanted to get specific information about that hero, you would add to the path name the ID. That's pretty common. So add maybe his IDs too, so then you get all the data for that hero from that endpoint. And then, say there's going to be some query params for some extra data that you might need for your feature. So you might have all these different types of query params, which is the example down here. But also, like if you're going to build a new feature, and then there's also another team building a new feature, you get a route, they get a route, it just routes for everybody. It just keeps growing and growing. Those have to be organized, they have to be maintained, versioned. So this is just framing the overall one of the drawbacks or problems of using REST endpoints. So I wanted to give context with this slide first. But in 2012, Facebook, their mobile apps were web views, and they were having performance problems. And for the first time, they needed to create a data API for their news feed before it was just rendered HTML from the server. And I really like this quote from one of their posts about GraphQL. We don't think of data in terms of resource URLs, which we just talked about with REST, secondary keys or join tables. We think about it in terms of a graph of objects. And that's like such a great part of this quote. That's what we're going to be looking at, graphs of objects. And the models we ultimately use in our apps, like NS objects or JSON, JSON, that's what it won. So yeah, it was really great to hear the mindset from this post. But what is it really? It's a specification for data querying with the primary purpose of loading data from a server to a client. It's a query language for your APIs. And if you think of SQL or SQL, that's a query language for a relational database. But this is a query language for your APIs, which is a different concept than we're used to with REST. It gives clients the power to ask for exactly what they need and nothing more. This is one of the benefits. It's the highlight of why people think about using GraphQL. But what is it really? When I was first learning GraphQL, I was like, okay, is this a new protocol or something? Like, how is this working? It's a HTTP post request. That's what it is, with the body being a JSON string, which is the query. So on the left-hand side, you can see we can use curl to get some data back if we're just playing around with an endpoint. Within JavaScript, we can use fetch with a post method, pass in as the body of the query. render it as JSON, or send JSON with the body. So it's just, this is what we're making post requests with different query bodies. So benefits and trade-offs. We mentioned it, but this is another way of saying it. Avoid over or under data fetching. On the left-hand side, you can see what our query would look like. We want to get a hero name, his friends, and the names of those friends. And on the right side, we see that we get that data in the same format back in JSON. Also, we're generally working with a single route. You're just adjusting your query and setting it to the same route. That's way different than having to think of resource URLs with REST, managing them. Just one. We're just going to work with one route. It greatly reduces the need for API versioning. When you think about changing a REST API, usually it's changing what data is being returned in some way. With GraphQL, you would just change the query, and you can still keep that data around for legacy versions or to make sure things aren't going to break for previous clients. It's easy to aggregate data. This is another common reason why people think of GraphQL. You have maybe some REST endpoints or data in many different locations. You can have one GraphQL API that just brings all that data in together, that can be queried in an efficient way. Avoids the N+1 problem with client data fetching. I want to emphasize on the client. Backend developing the API, you still have to think about the N+1 problem. For those that don't know, like on the client, if we were to get an array of heroes, for example, and then we wanted to get specific information for each hero, that's probably another API call. So you would have like maybe 10 heroes, and then which would be the array, and then you would have one data call for each hero. So fetching can really grow if you have this problem, but with GraphQL, we're just going to include all that information within the query and get all the data at once. So it's going to be one call to the API. Trade-offs. Query complexity. You can imagine that we can nest queries deeply. Some backends APIs are going to limit that, how far you can nest. Some even say you can only nest 2 layers. Some say 3. But there is complexity if you're going to be nesting more than that. Caching is more difficult versus working with a resource URL within REST, because normally you can cache based on the URL, but with GraphQL, there's only a single URL. People are changing the queries. There are GraphQL clients, little libraries to use on the front end that make caching easier, but it's considered a trade-off. It's also hard to rate limit. People are changing up their queries. That's a problem that you saw on the back end that can be hard. New security considerations. Usually GraphQL is a proxy for the REST endpoints. And if people are passing in bad query information that is getting passed on to REST endpoints, that's one thing that we're normally not thinking about if we're not using GraphQL. It's just when the backend has to transpile that information, it's something to be considered. That's one example, but there's more security considerations with GraphQL since it's different than REST. Adoption is not widespread yet. Still, it was open source in 2015. It's hard to say why exactly it's not as popular as people would thought initially, maybe because of these trade-offs above. But in comparison, React came out in 2013, also from Facebook. GraphQL is quite a great idea by itself. Okay, so this is the part I'm really looking forward to. Let's actually make some queries, and we're going to do that with the GitHub GraphQL API Explorer. With GraphQL, it's very common to have tools like this where you can practice making queries, see what data is returned. So yeah, let's check it out. This is a basic query. This is how it starts off. But everything in between, we have to learn how the GitHub API works to know what to query. So we'll go right to the documentation where we can look at what queries are available. I'm starting off with a query of the viewer, which is the currently authenticated user. And I'm authenticated within this Explorer. So when I make this query, it's giving me back my own information, my own user information. You can see here that there's types, which is identifying like what object it is and what fields it has. The exclamation mark means that it's required and must return back data. So keep that in mind. Let's move on a little bit. Okay, so how do we know what fields are available too? Let me just cover that. If we were to look at the user type, we would see that this is it. And these are the fields available. Avatar, URL, bio, created at, the followers. So, and that's, I'm querying some of that information here. But I wanted to point out that you can name your queries, and all that's for primarily is to, have your queries within the same document and still use this tool. Just choose which query to run. But other than that, no big difference. This is where it gets interesting. If we don't want to just see my information, we want to query another user's information. We can do that by passing in arguments. That's how we're going to query a specific user. And if we look at the GraphQL documentation for querying users, we'll see that the login, which is the username, is required, and it's a string. So, yeah, for simplicity, I'm still using my own user information, but next, now it's going to get a little bit more complex and in depth. I want to look at or get all the data for my followers. And if we look at the information here, it's within the user object. So followers, and it's a follower connection. And this was where a little bit of graph theory vocabulary comes into play. A connection is a list of edges. And so, this would be a node, and these edges is what's connecting the nodes. So if you want to, for example, this user here, if you want to see which posts he's authored, it would be an array of edges, and then that edge would have a reference to that post. This can be a little bit confusing at first if we're not used to working with graphs and we're coming along to this with a fresh set of eyes, but we'll look at the object in a minute. You can see that the arguments here, we can get the first set of number of users. number of followers. I'm going to use 5. So within my query, you can see I'm going to get the first 5 followers. And then let's look at the follower connection object. We can get the total count of followers. So I'm grabbing that. I want that. And then the edges are going to be all of the followers themselves. So let's look at a user edge. That object has a cursor and a node. The cursor is meant for pagination, and we're going to see that shortly. The node is a user, which we already seen the user object before. But you can see how this is getting nested. This is how graphs work. We're really getting into the levels here. And also quickly the page information, since I am going to be displaying pagination. Let's look at that object. We have these fields on that object, the start and end cursor to help know where we're at within the pagination, and then has next page, has previous page are Booleans, so we can disable left and right arrows within our UI, for example. Okay, so after a quick overview of like what what's available for us to actually query, this is what I came up with. So let's run this. And you can see I have a total of 11 followers. The edges, which are my followers, are, there's 5 here because I only requested 5. The cursor is the specific location identifier for pagination. But you can see down here, there's a start cursor, which is the first follower. The end cursor is the 5th follower. And then I have my has next page, has previous page. And there's no previous page because we're on the first page. So that's great. If I were to have like some pagination going, I got my first page of followers. Now I want to get the next page. You can see I have an extra argument called after. So it's the first 5 followers after the 5th user. And this is the cursor string that we're seeing over here. So we do this query, we get a new set of 5 followers. Now we both have a next page and previous page showing true. The start cursor is the 6th follower and the end cursor is the 10th. And we can do this one more time. And you see finally, I'm requesting the first 5 followers after the 10th, but I only have 11 followers. So I just have 1 showing here. I can't go forward to the next page. That's false. I can go back. But yeah, this is pretty cool. I really like the pagination aspect of this as well. But you can see if I wanted to still get other information like avatar URL, just add it in there. Boom, I got that information too for my client if I needed to. So yeah, that's a general overview of how to make queries. And I know it's pretty fast, especially if this nesting is a little bit new and a little bit of graph theory, but let's look at some useful links and what we can do next. The GraphQL documentation is great. I would recommend it. Remember, we're just making HTTP post requests. We can do this in any language. So they have language examples across the board. I would recommend playing with the GitHub GraphQL API Explorer. It was a great way to learn and interact with queries. And GitHub is something that we actually know, so it's kind of nice to at least have an idea of the end product and working with its API. Yeah, utilize a GraphQL client to build something. Relay is from Facebook. It's for React and React Native only. Apollo client is for React, but also all the other JavaScript frameworks that you guys like. These clients tackle a lot of the problems that have, or provide solutions to a lot of the problems that have already been come across within GraphQL, especially caching. That's a great reason to use the actual client. And then I really like this book by Rai. I'm a reader, so Learning GraphQL by Eve Porcello and Alex Banks, especially if you want to learn how to develop the backend API portion of GraphQL, I'd recommend it. I'm happy to answer any questions you may have, and thanks for listening.
Have you had a chance to use both Relay and Apollo? And which one do you find more to your taste?
No, I have not had a chance to use them myself, but so I can't give an opinion as of yet. But I hear, like, if you like React, go with the Facebook one. If not, Apollo is just as great.
Thank you.
Any other questions, guys?
Have you been able to use this on a large project?
No, actually, I haven't. It's just something I'm interested in. Like I said, REST is more widespread versus GraphQL. GraphQL has not taken over like they originally thought, but it is a cool technology and I like working with it. So I can't give any of my experience working at scale.
Well, thank you very much. It was a good talk.
Thank you. appreciate that.
So,
Yeah, I
so
had a question, Paul. I mean, so out of curiosity, kind of looking at how some of the different things work. I know, like you have like a query. There's almost like like a query language built into it.
Mhm.
I mean, where I guess like if you're looking at designing something, like how would you, like what would you say the benefits are of like using GraphQL over using something like I know like we talked about how if you have a lot of different routes, it can get kind of cumbersome. But say you have like not necessarily this might isn't necessarily best practice, but if you were to have something say like a singular route sort of situation, right, that returned say a fairly large like JSON object, and you just access the keys of that JSON object. I mean, how would that differ, or how does GraphQL improve upon that, if at all?
Yeah, so with REST, there needs to be some kind of foresight, and if you're trying to think of providing like all the data the client could need, you're gonna have a lot of data, like you said, maybe a very large JSON body. And depending on how large it is, that can affect performance. The whole idea of GraphQL is that you can have an endpoint with all the data available, but the client itself can really think about what it really needs and just grab that. So yeah, it kind of puts more of the thought about grabbing the data on the client side, and it can pick and choose versus having to think forwardly about, okay, what is all the data they need about this feature? I gotta make sure it's available with these handful of routes. So kind of flips it. It's more have all the data available and then let the clients just consume what they need.
Okay, so it kind of gives you the ability to customize, like without having to, like you were saying, without having to change the route. The client itself can sort of dictate the response that's going to get back from that API versus having to I guess having to just get a big object back and then do the parsing of that object response. You can kind of almost ahead of time filter out what you're going to get back from it via the query you provide.
Right. And in my opinion, that's way more flexible because you don't have to be as perfect thinking about what every feature is going to need ahead of time.
Absolutely.
Yeah.
Yeah, and I can add a little bit to that. So a good use case would be, say you have a product page, and then the information that you will show it on a product page for that product will be like really everything about the product, but then you might want to display that product on some other pages as well. Or maybe on mobile, you might need less information. On iPad, you might need more. On a web page, you might need even more. So you can really let the client decide how much of data and what kind of data the client wants to display.
Yeah, great question.
Nice. Good questions, guys. Any other questions?
Not exactly GraphQL related, but sort of similar vein, speaking on graphing like languages and technologies. Have you ever looked into or used Neo4j?
I've heard of it, but no, I haven't had to use Neo4j. And yeah, it's kind of interesting because this is a query language for working with APIs, not a query language for working with a database. So a little bit different, but definitely that knowledge of graph theory that you would get working with Neo4j would be applicable with how you're thinking about your data when using GraphQL. So
yeah, it's pretty cool. It's like you said, you kind of hit the nail on the head. It's similar in that they're both graphing, but one is database, one is APIs. But they share some commonalities, especially with things like like the cursor and pagination and things of that nature, and like the connections, that thought of here's how this data is connected to this data, pretty fun stuff. And I know Neo4j actually has a GraphQL library or plugin of some kind that you can actually utilize both. So if you have a database and you want to use GraphQL for your API to interact with that database, you can do so with Neo4j.
Nice. Yeah, I didn't know that. That's a nice tip. And yeah, I really like that quote from Facebook too, that's how they think about their data. They think about it of a graph of objects all being connected in some way. And that's how the idea was even born. So it's kind of cool to think about it from that perspective, because there was nothing like that before when they were building GraphQL. So pretty cool.
Any other questions, any other experience anybody wants to share? Really informative talk, really nicely done. And as a reminder to you all, we do these talks every Thursday at 5:15 p.m. Eastern time. And next week, James Putnam, who is a senior DevOps engineer with us, is going to give us an overview of Terraform, which is an infrastructure as code tool, which is used primarily to automate infrastructure tasks. And I'm really looking forward to this talk. Make sure you mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I'll see you all next week.
Sounds awesome. Thanks, Parag. Thanks, everyone.
Thanks everyone, and thanks Paul for doing the talk.
Absolutely.